You are watching video on SEE class 10 subject science. In this video series we are going to study chapters of physics, chemistry, biology, astronomy and geology. This part deals with physics chapter force, and this is part 2 of the chapter. In part 1 we studied about Newton's universal law of gravitation, and this part deals with universal gravitational constant capital G. Now in Newton's universal law of gravitation, we understood that the formula to calculate the gravitational force between two bodies is F equal to G m1 m2 divided by d square. Now in this formula, this capital G is proportional constant or proportionality constant. It is also called universal gravitational constant. And being a constant in this formula to balance force, okay, so this should have certain numerical value. It should have a value. And what is this value and how is it calculated? We are going to see here. And this capital G is also called universal constant because its value is same everywhere in the universe. Whether you measure it on the surface of the earth, on the surface of the Jupiter, on the surface of the moon, or anywhere on the earth, its value is going to remain same. That is why it is called universal, okay, universal gravitational constant. It is not affected by other physical conditions as well as chemical conditions, okay. Now we'll consider this. Supposing there are two bodies each having mass of 1 kg each, okay, and the distance between their centers is 1 meter. Right, now we are going to put these values in this formula, F equal to G m1 m2 divided by d square. Okay, now we'll put the value of m1 m2 and d from here. Right, so F equal to G, m1 is 1 kg, m2 is 1 kg and distance is 1 meter. M1 M2 both are of 1 kg and distance between their centers is 1 meter. So this condition is applied here in this formula. Now after calculation, how much do we get? So G, okay, 1 into 1, 1 and 1 is square 1. So 1 into G, G. So this way F equal to G, F equal to G. Finally we found the force is equal to G. That means this capital G, universal gravitational constant, is equal to the force when two bodies of 1 kg mass each are separated by 1 meter distance. Okay, so G is also a force, and from calculation it is found the value is this one, 6.67 into 10 to the power minus 11 Newton meter square per kg square. So when 1 kg mass are separated by 1 meter distance, the force between them is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So this is the value of this G, and which is equal to the force when two bodies of 1 kg mass each are separated by 1 meter distance. So G is universal gravitational constant and its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, so this is the value and it was found out by scientist Henry Cavendish. Okay, so from here we can define universal gravitational constant. How do you write the definition of universal gravitational constant? Now see, your definition is here. It is defined from here only in this condition. Definition: universal gravitational constant G can be defined as the force, it is also the force of gravitation produced between two bodies of unit mass or 1 kg, unit mass means 1 kg, separated by unit distance or 1 meter distance between their centers. So universal gravitational constant G is also the force because it is used to balance the formula of force, okay. Force of gravitation produced between two bodies of unit mass when they are separated by unit distance between their centers. Okay, so this is the definition of universal gravitational constant capital G. Now from this part you will get this type of questions. Okay, prove that F equal to G. For proving this you have to consider this condition, you have to write this way. Okay, supposing mass of first body, second body is equal to 1 kg, distance between their centers is 1 meter, then by putting this value here in this formula we get F equal to G. So this is the answer. Now it can be asked in another way also. Calculate the force when two bodies of 1 kg mass each are separated by 1 meter distance. So this is the way of asking questions from this part. Now we will see how to find the unit of G. Okay, how do we find unit of G? Newton meter square per kg square. How is it found out? Now unit of G from this formula, F equal to G m1 m2 divided by d square. Let's rearrange this equation. Okay, you know the cross multiplication. So while doing cross multiplication, G m1 m2 comes this side, left hand side, F into d square, right hand side. Again we can change the positions, their sides. F into d square comes to this side and G m1 m2 goes to this side. Or you can do this way also. G is kept over here on left hand side, and F into d square divided by m1 and m2 goes to denominator because it is multiplied with G over here, and when it goes to across the equal to sign it becomes division. Okay, so you know this one, F into d square, and m1 m2 comes to denominator. So G equal to F into d square divided by m1 into m2. So G equal to F into d square m1 into m2. Now force is measured in Newton, right, and distance is measured in meter SI unit. Mass is measured in kg, another mass is measured in kg. So this way Newton meter square divided by kg square. Okay, Newton meter square divided by kg square, or Newton meter square divided by kg square. It is written this way also, or if we write it this way, Newton meter square kg to the power minus 2. To the power minus 2. When it is made inverse, then the power becomes inverse minus 2. Okay, either this way or this way. So this is the unit of G. Newton meter square per kg square is the unit of G. Universal gravitational constant value and unit of G we'll see here. So by taking this formula, by doing cross multiplication, rearranging the equation, and it is the same way, right? Or there should be or, right? So finally we have got Newton meter square per kg square, and it is written this way also, and its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. This is the value of G, and it is also called universal value, universal gravitational constant. This value is constant everywhere in the universe, whether you measured it on the surface of the earth, on the surface of the moon, on the surface of the Jupiter, anywhere on the surface of the earth, its value is going to remain same. Okay, that is why it is called universal gravitational constant. Now this value 6.67 into 10 to the power minus 11 is a weak force in nature. It is the force between two bodies of 1 kg mass each. Okay, it is the weak force in the universe. So this force cannot be noticed or experienced because this is very small force. That is why the force between bodies of small mass cannot be noticed or experienced. Okay, so an apple is attracted towards the surface of the earth. We have seen that apple falling downward towards the surface of the earth. That means the surface of the earth is attracting apple towards it. Now this attraction can be seen, okay, it is because gravitational force can be experienced when one of the body is large as earth, very large, very big, example earth. So the apple falls downward due to the force exerted by the earth on it. So gravitational force can be experienced when bodies are very large as celestial bodies, okay, as large as earth. Okay, so in case of small bodies, in case of the force between a building and tree, that force is also cannot be noticed, okay, because that is a small mass compared to the mass of the earth, right? So the universal gravitational constant 6.67 into 10 to the power minus 11 Newton meter square per kg square. This force between two bodies of 1 kg mass cannot be experienced or the noticed gravitational force between small bodies with small masses cannot be noticed or experienced, but the force is present there. Okay, now relating to this topic, there are this type of questions. Define universal gravitational constant. Okay, give number 2, give the value of universal gravitational constant with its SI unit. These are the questions. Okay, now G is a universal constant. Why it is universal constant? Okay, so this is the question. Prove that F equal to G, or find the value of G when two bodies each of 1 kg mass are separated by 1 meter distance. So these are the questions related to universal gravitational constant. And there is a small topic which is not of universal gravitational constant particularly. So write down the consequences of gravitational force, or what is the significance of gravitational force. So this is a small topic here. Now, consequences of gravitational force, results, significance of gravitational force. The planets revolve around the sun, and existence of solar system is due to gravitational force, or all celestial bodies are in their positions because of gravitational force between them. Gravitational force causes the presence of atmosphere on the earth. We have atmosphere on the surface of the earth because of gravitational force. We live, walk on the earth due to gravitational force. Okay, we feel our weight on the surface of the earth due to gravitational force. Tides occur on seas and the oceans due to gravitational force. Okay, there is a force between moon, sun and the earth, and that causes tides on seas and the oceans, and mainly it is because of gravitational force of the moon on the surface of the earth, because moon is very close to us, okay, compared to the sun. Things fall down and water flows downward due to gravitational force. So these are all the consequences or significance of gravitational force. So with this we finish this part. In the next part we are going to do gravity.